So in this video, I'm going to talk about how to plot a velocity time graph from a given position time. So here in the first column, we have the time, and then we have a position, which is a function of time. So what does this mean? At time equals to 0, that is when the clock started, our position was 5 meters. And at 0.5 second, my position was 3.75 meters. So let's first plot a position time graph. So we're going to select these two columns, go to insert, and then select this scatter graph. And now once we need to know how does this dots vary, or how does this data points vary, or what is the equation of this variation. So in order to answer, you can either click onto this plus sign, or you go to this plus sign here, and then you see the trend line, more trend line options, and this is a linear line here. So this linear line is clearly not a best fit. So what you have to do is go to the polynomial order 2, and you can clearly see this is a much better fit now. And in order to know the equation, simply click onto the display equation. So that's how does the position time graph changes. And now I have to clearly label all this axis here. So what I'm going to do, simply write down the position time graph here. This is my position time graph, and go to the plus sign and go to the axis title, and here this is my position. The position is in meters, so write down the unit as well, and this is my time, and the time is in second. Okay, so this is my position time graph, and you can select any colors here. Here you can select the whatever you like. Okay, so let's select this one now. Once we have the position time graph, we have to draw the velocity time graph. So let's do it. So we have to make another column. So let's call this one is a velocity. So how the velocity is defined? The velocity is defined as a change in position divided by the change in time. Correct? That's how the velocity is defined. That means we need to know the change in position. So here we're going to use the derivative. So that means the change in position is this minus this would be my change in position. And this change in position happened between these two times. So this is my change in time. Within this time, 0.5 second, this is the change in position it happened. So that's my velocity. Once I have this formula, so what I can do, I can simply drag it, and that gives me the velocity equation. If you want, I can put the 0 here too. And now I'm going to plot the position time graph, or you can simply leave as it is. So now once you have this, go back here and then draw. I will just simply remove 0 here. All right, so this is my velocity, and the 0 would not make sense because it has to start from the negative number. In fact, it has to be -5, and I will explain why -5. But now, so this is a velocity time graph, and this is a linear fit. So in order to understand the equation, go to the trend line and more options, and then display equation here. So that's my equation, 10x minus 10.5. Okay, So that's how does the velocity change. Once you have this velocity time graph, you have to write down here velocity time graph, and then click onto the plus sign, access title. You have to make a note here. This is the velocity. And the unit is meter per second, and this is a time which is in second, right? So that's my velocity time graph. So this one is. Now we need to know the acceleration. How does the acceleration define? The acceleration is defined as a change in velocity divided by change in time. So we have to find out the change in velocity. So in order to do that, this is my change in velocity. The change in time would be this. This is change in time would be this minus this. That's my change in velocity. So this gives my acceleration. And once I have, you simply have to click it and then drag it. So that is my acceleration. Okay, so let's plot the time and acceleration graph. So select time, select acceleration, go to insert, and then go to scatter graph. So here, this is an acceleration time graph, and again, you have to clearly label the axis. And assign, go to axis title, and this is an acceleration. What's the unit? Meter per second square. And this is my time, and the unit is second. And if you want, you can also draw a trend line, and you see that this one does not changes with the time. So if I go to time and linear, so this is a linear, and then you can also do the display equation. So I'm simply going to display equation here, which is saying that this is a constant quantity. It does not change with the time. So this is how we plot the velocity time graph and acceleration time graph from the given position and time. Position as a function of time. So what is the conclusion? What we can draw information? The information is, if acceleration is a constant quantity, the velocity would be a linear function, and the position would be a quadratic function. Or in other words, if position is a quadratic function, the velocity would be a linear function, and acceleration would be a constant quantity. A simple example would be, if you have a ball and if you drop a ball from a height, the acceleration is constant at each point. That means during the free fall, the velocity would increase linearly and the position would increase as a function of second order power or quadratically. Okay, so this is the conclusion that with a constant acceleration, you'll have a linear function of time and a quadratic function of position. So this is it from this graph, this video. If you have any questions, write to me. I hope you have a wonderful time. Thank you very much.